we're gonna be doing a coding stream today. It's a Wednesday, and today we're going to be studying a little bit of Solana and Web3 blockchain stuff. So I'm quite interested, excited to go through this learning session with you. Yeah. Let me just reduce the volume a little bit. Just find that sweet spot there. Okay. So before we get started, I just want to share that I just recently started this YouTube channel of mine called The Gaming Classroom, and it has its own invitation for a Discord channel that you can join. I'll probably put it on the About page later on. But I have some pieces of content that I've been making, and I hope to add more of the streams that we do on this Twitch platform here as well on the Gaming Classroom. So yeah, let's get straight to it. Let's do some Solana programming. So what I want to accomplish today is tinker around with the token program. So making your own fungible tokens. That's one thing. So we'll just go through this guide, follow it, and see where we find ourselves. I'm just gonna go and check on something first before we get started. And we're back. Okie dokie. Let's get to it. Okay. Do we do token program first or read some white papers? Let's read the CEO of Solana's blog post 3 years ago about SeaLevel. Yeah, let's just reduce that a little bit more. Okay. So let's see what we actually understand about SeaLevel. So SeaLevel, parallel processing thousands of smart contracts. Okay. Smart contracts, it's just basically programs, right? Okay. And parallel processing, you want it to run all at the same time concurrently or in parallel. Understand one of the 8 key technologies that make Solana the most performant blockchain in the world. Okay, let's see. So it's the most performant, does 50,000 transactions at a time. I think the volume went a little lower. Let's just increase it. It's transitioning to the next song. Okay. Achieving this requires implementations of several optimization and new technologies. Okay. So 8 key innovations that make Solana network possible. Today we're going to be reading about SeaLevel, which is how they enable parallel smart contract runtime processing, processing of smart contracts. Okay. Before we start, one thing to consider is that EVM and EOS's WASM-based runtimes are all single-threaded. So this is WebAssembly, I think. So I don't know what EVM and EOS stands for, so let's go look that up. Ethereum Virtual Machine. So it's a comparison for its competitors. What's EOS? EOS blockchain or Web3? This is decentralized operating system. Electro-optical system. Claims to eliminate transaction fees and conduct millions of transactions per second. Haven't heard of that. But okay. So it's comparing itself to Ethereum and this EOS that I haven't heard of before. But we'll move on. We don't really need to dig deep. We're going breadth first before we go deep. We'll keep it in mind. EOS. What does EOS mean? Electro-optical. Why? Why is it called electro-optical? Supports core functionality. It wants to be bigger, better, faster. 15 transactions. Millions of transactions. Right. Okay, sure. Basically a competitor. We can check it out later. The reason Solana is able to process transactions in parallel is that Solana transactions describe all the states a transaction will read or write while executing. This not only allows for non-overlapping transactions, to execute concurrently, but also for transactions that are only reading the same state to execute concurrently as well. Okay, makes sense. Yeah, okay. Programs and accounts. Cloudbreak, our accounts database. So this is another one of their key technologies, Cloudbreak. I haven't read about this yet, but it's their way of recording accounts on the Solana network, I guess. Our accounts database is a mapping of public keys to accounts. I don't know what they mean by public keys. So if you don't know, you ask. Public key Solana. What is a public key in Solana? Let's check that out. This document describes how to create and use a paper wallet within Solana CLI tools. Provides a key generation tool to derive keys from BIP39 compliant seed phrases. I don't know what BIP39 means, so let's go read it out. So in Bitcoin, BIP's MediaWiki. So this likely shows up as some kind of wiki page. I would assume. Is there a link to it? Bitcoin improvement proposals. So that's what BIPs means. Was it 39? BIP 39. Okay, let's read BIP 39. It says, applications, mnemonic code for generating deterministic keys. Okay, then proponents, standard proposed. Okay, let's read it a little bit. Abstract. The BIP describes the implementation of a mnemonic code or mnemonic sentence, a group of easy to remember words. Okay, so I've experienced this before in other blockchains, blockchain networks or wallets, where you just give it 10 distinct phrases and then it's a way to generate a wallet already. So it consists of two parts, the mnemonic and converting it into a binary seed. Seed can be later used to generate deterministic wallets. So that's what it is, BIP 32. Then this is just the algorithm. Then the word list. So it needs to be not really densely packed. It has to have some sparsity. The different words used shouldn't be too close to each other. Sorted. Yep. Having things sorted. Optimization sounds good. Okay, we don't need to read more about it, so let's just get back. So derive keys from the seed phrases. So I think generally how those words are used is for it's like a key, right? It's your way to get back to your wallet, and that's why blockchains actually tell you to keep your 10 words safe, like write it down, put it in your vault, so that you can get back to your wallet just in case you lose it, right? It's your key, it's your mechanism of getting back your wallet. Okay, moving on. Paper wallet usage, Solana commands can be run without ever saving a key pair to disk on a machine. If avoiding writing a private key to disk is a security concern, you've come to the right place. So this is creating a new paper wallet using Solana keygen. New. After copying the seed phrase, you can use the public key derivation. And then this is your public key. This is the binary data. It's your wallet address. Okay, sure. All right, I'm done reading this, and let's go back to this one. Okay. So Cloudbreak, our accounts database, is a mapping of public keys, which is basically the reference to your wallet to some account on the Solana network. Okay, that makes sense. Accounts maintains balances and data, where data is a vector of bytes. Okay. Accounts have an owner field, right? Who owns it? The owner is the public key of the program, right? Which is right the byte, the hash or weird words that you find, the weird letters. That's your public key that governs the state of transitions for that account. Programs are code, or smart contracts are code, and they don't have any state, right? They just are used to run things. They rely on the data vector in the accounts assigned to them for state transitions. So it's on the account. So Cloudbreak is the one that holds their accounts, and that's where you, I guess that's where you store your data. It's maintained there. Programs can only change the data of accounts that they own. Okay. Programs can only debit accounts that they own. Okay. So my understanding here is that I might have a wallet of mine, right? I produce my own wallet, but when I interact with some kind of smart contract or a program, it generates its own kind of sub account on my primary account, and that program owns that sub account. That's why they can debit and facilitate changes on that sub account. That's my guess right now. Might be incorrect, but we'll see. Any program can credit any account, right? They can move funds to another account. Any program can read any account, so everything's public. By default, all accounts start as owned by the system program, and by system program, I understand this to be Solana's operating system. System program is the only program that can assign account ownership. It's a program that can allocate zero initialized data. Assignment of account ownership can only occur once in the lifetime of an account. Okay. A user-defined program is loaded by the loader program. The loader program is able to mark the data in the accounts as an executable. The user performs the following transactions to load the custom program. There we go. So if you're loading a smart contract, right, it creates a new public key. So I'm guessing that's like the sub account that I was referring to. It transfers coin to the key. Okay. That's what the user does. Okay. Tells the system program to allocate memory. Okay. Right, because if you want to allocate memory, you have to spend for that. That's why you're putting some value there. You need Solanas to do that. You tell the system program to assign the account to the loader. So this account will be used by this thing loading the program. Upload the bytecode into memory in pieces and tell the loader program to mark the memory as executable. Okay. At this point, the loader verifies the bytecode and account to which the bytecode is loaded into. The loader verifies the bytecode and the account to which the bytecode is loaded into can be used as an executable program. New accounts can be marked as owned by the user-defined program. Right, because if they are owned by the user-defined program, then that program can access those sub-accounts, right? They can facilitate deductions or debits from that account. The key insight here is that programs are code, and within our key value store, there exists some subset of keys that the program and only that program has right access, right? So it's a sub account, right? It's like automatically registering under Facebook, except you're paying for the funds to maintain that, I think. You, or maybe I'm not entirely sure. We'll see. Transactions. Transactions specify an instruction vector. Each instruction contains the program instruction, and the list of accounts the transaction wants to read and write. This interface is inspired by low-level OS interfaces to devices, which is read. So this looks a lot like just some interface definition and some structure or type definitions. This likely is Rust, I'm not sure, or maybe C++. Or looks like C, actually. Looks like C. So it's read vector integer D. It's a structure to an IO-vec, and it's a pointer to an IOV. It's a pointer to this. This is the data type. This is the variable. This is the data type. This is the variable. It's a constant, can't change. And IOV count. That's the variable name. Okay. Then IOV base is the start of that input. It's a pointer to that address. Size t, this is the length of the instruction vector. Okay. Interfaces such as read v or write v tells the kernel ahead of time all the memory the user wants to read or write. Yeah, it tells you which instruction and how many. All of the memory the user wants to read and write. This allows the operating system to prefetch, prepares the device, and execute the operation concurrently if the device allows it. That makes sense. If I'm accessing memories from 0 to 10 and someone else is accessing memory from 110 to 120, then there's no conflict. So the operating system can prefetch and analyze that. Okay, not sure how they do that, but okay, we'll move on. On Solana, each instruction, we have 2 viewers. Hello there. Feel free to just throw questions because I am also studying this thing and I am not really that sure yet of what I'm studying. So let's study it together. So on Solana, each instruction tells the VM, the virtual machine, which accounts it wants to read and write ahead of time. And that's how they do their optimizations, right? Which instruction and how many. Okay. What's more is that we can take advantage of how CPUs and GPU hardware are designed. So I'm not sure what SIMD means. Let's check it out. SIMD CPU. Single instruction, multiple data. Is a type of parallel processing. Can be internal, part of hardware, or accessible as an instruction set architecture. Shall be with ISA. Describes computers with multiple processing elements that perform the same operation on multiple data points simultaneously. So it's for parallel processing, functionally. Okay. So 132-bit register access for 8-bit registers. So these are registers, and they have 32 bits, and each the 32-bit can be split up into 4 parts, and each 4 part is 8 bits. So 8 bits, that's 2 raised to the 8. How many bits is that? 256. Okay, so you can reach up to, if it's unsigned, you can reach from 0 to 255. Okay, clear. So your RAM has your input 8-bit numbers. Okay. So if you give it 1928, the result is 327,624. I know that's the register one. Maybe these are just illustrations that don't really have that much detail. Okay, let's just move on. It's okay, we don't understand. SIMD instructions allow for a single piece of code to execute over multiple data streams. This means that SeaLevel, the technology they built, can execute an additional optimization which is unique to Solana design. Sort all the instructions by the program ID. Okay. Run the same program over all accounts concurrently. Okay. Because they're sorted by their instructions. Right, which is this one. Right, which instruction is being run, I think. That's how I understand it. To get an idea of why this is such a powerful optimization, take a look at Cuda Developer Guide. If I remember, Cuda is like a graphics processing, NVIDIA Cuda, right? Parallel computing platform. Okay. So the Cuda architecture is built around a scalable array of multi-threading streaming multiprocessors. So when a Cuda program on the host CPU invokes a kernel grid, the blocks of the grid are enumerated and distributed to multiprocessors with available execution capacity. What did I understand from that? Okay, Cuda is an architecture used in NVIDIA's specific graphic cards used for parallel processing. Okay, it's built around a scalable array of multi-threaded streaming multiprocessors. So I think these are like hardware stuff that allow multi-threading. When a Cuda program, so it's a specific way of programming, on the host CPU invokes a kernel grid. Invokes a kernel grid. I'm not entirely sure what that means. I know kernel is like a little synonymous to operating system. The blocks of the grid are enumerated and distributed to multiprocessors with available execution capacity. Just figures out who's available and then they process it. Okay. While a multiprocessor can execute only a single program instruction at a time, it can execute that instruction over 80 different inputs in parallel. So if the incoming transactions are loaded by SeaLevel all call the same program instructions, such as CryptoKitties, BreedCat, Solana can execute all of that transactions concurrently over all the available CUDA cores. That makes sense because you're processing the same program, but you're just changing the byte data that you're going to be processing, which is on the accounts, which is just the bytes, but you're running them all through the same thing. Okay, that makes sense. There's no free lunch in performance, so for SIMD optimizations to be feasible, the executed instructions should contain a small number of branches, and should all take the same branch. The multiprocessor is bound by the slowest path execution will take in the batch. Even with this consideration, parallel processing via SeaLevel presents a foundational development in the way that blockchain networks function compared to single-threaded runtimes, enabling exceptionally high throughput and usability. Basically, what this means for me is if you want your system to run fast, then you need to write your Rust code really well. You gotta do those byte stuff really quickly, very intelligently, so that it runs properly on CPUs and GPUs. Okay, we can do that. So that's 20 minutes. We just read some piece of content about SeaLevel, which is Solana's key technologies. Let's go ahead and try something more concrete. So let's try to play around with this token program. Last time we did a stream on Solana, we actually ran the break the Solana network kind of program. We were able to play with it on the dev test network, and we tried to run it on the local network, but we weren't able to completely make it run properly on our local network, and we didn't get to go back to it. So let's go ahead and do this one. Token program. Program defines common implementation, fungible, non-fungible tokens. Okay. Token program is written in Rust. Auto-generated C bindings, JavaScript bindings, CSPL. I can't remember what SPL is. Solana programming language, I think. Solana program library. Collection of on-chain programs targeting the SeaLevel parallel runtime. Okie dokie. Associated token account for convention around wallet addresses to token account mapping and funding. Okay, let's go ahead and do it. I think I still have cargo here. So let's go see what that's like. So I do have cargo. Experiment SPL tokens. Let's do this one. Run SPL token -- help for a full description of available commands. And then configuration. The SPL token configuration is shared with the Solana command line tool. Then we just do Solana config get, and then what configuration it's pointed to. I think I'm pointing to my local Solana, but I don't, like, for sure my Solana's not running. So we're gonna have to projects, I think. CD Solana. Yep, we were doing the break thingamajiggy. Still downloading. Okay. So let's check out what the Solana configuration says. So it's pointing to the local environment, but that means that I also have to make sure my Solana is running. So let's look at my previous Solana commands. I think it's this one. Solana test validator, right? That makes sense. Run the validator. Now it's on, right? It's running on 8899, WebSocket 8900, blah, blah, blah. So I think at this point, Solana is already running. Solana logs. Is there some kind of way for me to see the logs? I remember there we go. Solana logs, confirm commitment. Yeah, it's gonna just keep showing me the logs now if I do any changes. So let's move on. Okay, I think we're done here. Failed to compile. Intermediate artifacts can be found. Package required. It's the cargo feature called Edition 2021. But that feature stabilize 1.55. So we need to install the latest version of cargo. No worries, we can do that. Cargo latest version. .55. Now we want to update, so we'll just do rust update stable. Pretty good. That's a thumbs up. So while we're waiting, let's just keep reading what we can so we don't waste time. This is running. We can do something here. Okay. We did the Solana config get. We're done with that one. Then it also has a key pair, right? Yeah. Hardware wallet, config, key pair, USB ledger. Airdrop, Solana. Creating tokens and accounts requires Solana for account rent deposits and transaction fees. If the cluster you are targeting offers a faucet, you can get a little sol for testing. Yes, it is. Yes, we do have a, but I can't remember my thingamajiggies, my wallets. So I guess it would be this one, right? I guess. Hi. Can't remember how to check. Solana, check wallet value. Solana CLI, check wallet. There we go. Check balance. Get balance. Solana balance. Okay. But I want to see the balance of a specific thingamajig. Okay, we can specify the account address, so we can do this one. There we go. So it has 1 sol, and if I do another airdrop, then we check the balance, it's 2 sol. Okay, makes sense. Where were we? We're just waiting for this one to finish, and it's done. And then if we do Rusty version, cargo version, everything looks good, then we just do install the SPL token again. Okay. Create your own fungible token. So there's an SPL token command. Oh, it's just there. We just okay. You just create a token. Create your own fund. That's it. I just run this one. The unique identifier of this token is because it's that one. And there's the signature. And then I just supply that token. Oh, we check the supply of that fungible token. There's 0. Let's mint some. First, create an account to hold the balance of the new So create an account using the same address. And then I created that account. Now it's an empty account. And then it has a signature. I'm not entirely sure what the signature is for. So let's go check that out. So I could be reading other people's tutorials, but I want to read just the standard documentation. I want to understand what SPL token means. SPL token, create account. And then let's go ahead and read that. So create account, create a new token account. Then flags, options, token address, account key pair. Okay. The token that the account will hold, specify the account pair. This may be a key pair file or the ask keyword. Dump transactions, fee pair. Specify the fee pair account. This may be a defaults to the client key pair. URL for Solana's JSON RPC or moniker. Yep, configuration says it's localhost. Ooh, nonce. Okay. Address of the token's owner. Okay. Fine. It's still not done. Wow, okay. Sin clap regex. It's saying here that the connection is laggy, so let's fix that. The connection buffer says ano naman? Hi. Let's see what that looks like here. Yeah, the video's buffering and it's unstable. We can try to fix that first. Oh, because I'm downloading, that's why. Oh, okay. So I have to actually consider that. But it's building, it's not downloading. So let's see the system network. Okay, chat, we are back. This time though, we finished our build here, so that's good. My machine was basically full on using all of its CPU resources, and this one a while ago was just full on 100%, just putting in the work, and that was affecting the stream. I couldn't upload as much as the network actually Twitch needed me to. So let's move on and resume what we were doing. I'll just monitor the connection and see what's going on. Yep. Okay. Right. So we finished doing SPL token, so it's available now. Now we just need to follow the instructions. We have one already. We have our own wallet, but we will be creating our own token. So let's do that. SPL token, create token. Ta-da! I have a new token. But then when we check its supply, it's still 0. There's no amount on that token. That makes sense? So let's mint some. First, create an account to hold the balance. So we'll create a new account. And it's the same thing, right? AQ. Let's do that. And we're done. And then when we check the balance of that account, we'll notice it doesn't have any. AQ, blah, blah, blah. So we want to mint them. So we'll go ahead and do that. But we have to specify how many. So we'll do 100. So the token supply and account balance now reflect the result of the mining, of the minting. So let's do that. Supply and balance. Okie dokie. Example, view all of the tokens that you own. So let's see, SPL token accounts. So there's that one, okay. When you want to wrap Solana, you can send Solana to an associated token account on the native mint and call sync native. Sync native updates the amount field on the token account to match the account of the wrapped Solana available. I don't know what wrapped Solana means, so let's go ahead and find out what that means. What does wrapped Solana mean? Our Solana. Asking the right question. You don't understand it, you ask the right questions. Okay. So moving on, revenue new. I tried to convert Solana through FTX to a different coin, but when I went in to check my wallet, it showed as wrapped Solana. I was able to unwrap it, but after trying to look up, I didn't have any luck. But cryptos with smart contracts have a wrapped version. All of the tokens on Solana are smart contracts at their core, and many of the things we do, like swapping tokens, depend on standardized functions in these smart contracts. So wrapped Solana is Solana in token form, mainly so that you can swap it for other tokens on something like Serum. You can also have wrapped Sol on Ethereum. That is a token that represents Solana on the Ethereum blockchain that can be bridged back over for normal Solana. So it's all gotten fairly convoluted, but wrapped Sol is just basically Solana as well. You can also find different forms of wrapped Ethereum on Solana, on Radium, blah blah blah. There will be different letters in space of the W depending on how it's bridged over. Wrapped Sol is the token with a value of 1:1 to Sol. This is somewhat applies to Solana as well. Okay, so it's just the same thing, except it's different. It's just a way to bridge the cryptocurrencies across the different networks, blockchain networks. Okie dokie, that's enough for me. Okay. Wrapping Solana in a token. When you want to wrap Solana, you can send Solana to an associated token account on the native mint and call sync native. Updates amount on the token to match the amount. That Solana is only retrievable by closing the token account and choosing the desired address to send the token account's LAN ports. Okay, let's try that out. SPL token wrap 1. Okay, so if we try to look at all of our accounts, we find that there is some wrapped Solana, I guess. Let's try to wrap another one. Account already exists. Wrapping into DF blah 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 blah. So it's saying, that means that I wrapped Solana, but only of amount 1, and it created it into this wallet, or what they call an associated token account. And it matches the balance somewhat after paying the fees to match the amount of wrapped Solana available. To unwrap the token back to Solana, then we need to unwrap that specific thing. So SPL token unwrap, and then we say this one. Okay, we unwrapped it, and when we check the balance again, we're good to go. Okay. Surprisingly, the fees, there wasn't any deduction. Well, technically, it's still there, actually. But okay. Example, transferring tokens to another user. First, the receiver uses SPL token create account to create their associated token account for the token type. Then the receiver obtains their wallet address by running Solana address and provides it to the sender. Okay, so let's try that. So for example, I'm the receiver. So SPL token create account, right? I need to give it some address. Let's say it's exactly the same thing as this one, except we'll put 1, 2, 3, 4, 5, 6, and then put Darren in the start. Invalid value. Okay, we can't do that because we need to first create an account. But I am trying to create an account. Okay, so how do we create an account? I think it's create token. So let's do that first. Wait, create token creates a token, not the account, right? Yeah, this is a fungible token, but what we're trying to do is we're trying to create our own wallet. At least that's how I understand what we're trying to do. Invalid value, no such file or directory. Okay, so I had a wallet already a while ago. So what we can do is transfer from the wallet that has this much Solana. Alright. Is it this one? AQ. No, it's supposed to be this one. 5U. Alright. What's DFU? DFW. DFW is the sub account for the wrap token, right? Then 5U is the newly created account. 5U is the newly created token. 5U is the newly created token. 5PG is the account for that newly created token. Okay, clear. So we're transferring from the newly created token that we made, and we're sending it to the token that we had before, which I think would be here, right? So we can do Solana balance. This is my token. Does this work? Transferring 50 tokens from sender 5U, 5PG, right? The sub account, and the recipient is EVT. Recipient associated token account does not exist. So we want to fund that user. So let's do that. So I think that's gonna automatically create the sub account for that user, maybe. Hi. So if I do Solana balance this one, I still have 2. But then if we check, what's the way to check their account? It's SPL token accounts. Help. Okay, so we can specify the token address. So we specify the token address of this one. Does this work? No, not this one. I think it's this one. This is the token address. There's 50 now. So we transferred. I think ito yung nilagay niya ng fund recipient, right? Yep. Right, so yun, we created a fungible token, but my question is, then the receiver obtains a wallet by running Solana address. No, I think this is the main admin account currently. Okay. So we transferred some tokens. SPL token. Account info. Then let's check out this account, which we sent some stuff to. So that's not a token account. I just want to see the wallets accounts of this one. So we minted and then we sent it to this account, but then how does this account verify the tokens that it has? So let's ask that. Solana, how to find out tokens that I have. Let's check that out. Solana CLI. Send and receive tokens. Let's check it out. Testing. Solana airdrop, Solana confirm, Solana balance. Maybe it's Solana balance. Haven't I done that already? I think I have. Solana balance, this one. I still have 2, but this is how much Solana I have. I want to know what tokens I have. So how do I find out what tokens I have? Receive tokens. You'll need an address. In Solana, the wallet address is the public key of the key pair. Blah, 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 blah. Before receiving, you'll need to create a wallet. Did I create a wallet? I don't think so. So the receiver has to create a wallet. Once completed, you should have a public key for each key pair you generated. The amount, fee payer. Okay. So I have 2 Solana, but how do I check the tokens that I sent to myself? I feel like it's gonna have something to do with SPL token, because it's not just Solana by on its own. It's token related. Account info. Is it address? So I think it's owner. Does that work? No, I need to specify the token. Close a token account, burn tokens from an account, token benchmarking, get token account balance, authorize a new signing key pair to a token or token account, approve a delegate for token account, get wallet address. Is it address? No, not address. Lit all token accounts by the owner. So what was that? Accounts? Oh. Let's do owner. There we go. So this is the CLI command to find out that we received this many tokens. Right. Okay. That's super duper cool. Okay. Awesome. So what if I want to send from this one to another one, right? Like we just did the transfer a while ago. What if I want to, like, let's say, give it back? Transferring tokens to another user. First, the receiver uses SPL token create account. The receiver okay. Transferring tokens with sending funding. Okay. So if we do SPL token from this account, right? 50 going back to this account. Does that work? Oh, sorry, my bad. SPL token transfer. Account could not be parsed as token account. Public key. Oh, I think the transfer command needs a token as its first parameter. Token address, amount, recipient address. Right. Yeah. So how do we potentially put it back? Let's see. SPL token transfer. Transferring tokens to an explicit recipient token account. To a specific, the recipient token account must already exist and be of the same token type. SPL create account. It has its own signature. Well, what does this key pair mean? I'm not entirely sure. And why did our music stop? I can't hear anything. Is that just me? Yeah, it's just me. Oh, hi. Is my earphones being buggy? Oh, hi. So we're transferring tokens to an explicit recipient token account. So first it creates an account with some key pair. So I don't understand what key pairs are. So let's go find out what that means. Solana key pair. What is it? Many commands using the CLI tool requires a value for a key pair. The value you should use for the key pair depends on what type of command line wallet you created. For example, the CLI helps shows the way to display any wallet also a key pair subkey is this one. Below we show how to resolve what you should put in your key pair depending on your wallet type. In a paper wallet, the key pair is securely derived from the seed words and optional passphrases you entered when the wallet was created. To use a paper wallet key pair anywhere, the key pair text is shown in examples or help documents. Enter the URI scheme of the prompt. Prompt : / and the program will prompt you to enter your seed words when you run the command. Oh. With the file system wallet, the key pair is stored in a file on your computer. Oh, hi. Replace key pair with a complete file path to the key pair file. For example, if the file is about hi. So I want to make, so let's try doing that. Let's make a wallet. Let's make a wallet that uses a file system wallet. But it's the least secure form of wallet. Oh, I didn't know that. It's convenient because the key pair is stored in a simple file. You can generate as many keys as you like and trivially back them up by copying. It is insecure because the key pair files are unencrypted. If you're the only user of your computer and your computer is free of malware, a file system wallet is a file system. If, however, your computer contains malware and is connected to the internet, that malware may upload your keys and use them to take your tokens. Likewise, because the key pairs are stored on your computer as a file, a skilled hacker with physical access to your computer may be able to access it. Using an encrypted hard drive, such as File Vault, minimizes that risk. So the concept of wallets is just a matter of where are your passphrases kept? Is it written down on paper or is it saved on a file? That's what it means. And this is just basically how your mechanism to get back to your wallet. That's fundamentally it. Oh hi. That's why it has a parameter when you're using the Solana CLI to specify which wallet are we talking about, because we're trying to derive the reference to which account, and you can specify it using the prompt. So you can enter the 10 words, or you can use the key pair file system file path kind of thing. Or if you're using a hardware wallet, you use USB. Cool. Makes sense. Oh, hi. Let's go back to what we were trying to do in the first place. We're trying to transfer the contents back to an explicit recipient token account. So let's just try doing that. SPL token create account. And we're creating an account using this guy, but it already exists. Oh, hi. So this is where we actually should do the transfer. Am I right? AQO 50 CQV. Oh, hi. So if we do, what's this? Oh, hi. If we transfer from, this is going from, yeah, we're gonna reverse this one and then put it here. Account couldn't be parsed as a token account. Token address, token amount, recipient address. Okay, so what we can do is from sender token account address. So So this is from here going here, right? And then we still need to specify what token. So it does the validations for me. I get it now. So we need to specify which token. And our token is this guy. Is this the token? Yeah, there's 100. Yeah, yep. This is the token. And then we're saying we want to transfer. So the token address, token amount 50, right? And then this is from this account going to this account. Bam. Okay. Account could not be parsed as token account. EVT. It's not a token account. From sender token account address. Alright, because this isn't the token account. I'm being silly again. It's this one. This is my token account. Right. This is my token account. No, this is my token account. Going back to this one. Still no. So 5U is wrong. It's supposed to be... But isn't that right? This is the... Yeah, this is my account. This is my wallet. This is my token account. Right. So if I do this one, this is my token account. From this one, going back to going here. But isn't that the same thing? 5UG with RPP? Yeah, it is. Oh, hi. So we're kind of confused here. Oh no, this is saying what token I own, right? But what's my address? We can actually find out here. Recipient associated token account. This is my recipient token account. Can I reverse it? From this guy? So the sender is shy, the recipient is 5U. Oh, hi, so this is wrong. This is wrong. What we need to send it to is the original owner, which was this one. But that was what I wrote down. Okay. What's making sense here? This is the token address. And we want to send 50 of this token. We're sending it from the users, from the user that received it to this account. Does that make sense? No, it's saying you're trying to transfer 50 from this guy to this guy, and the token account address is this one. So let's try to do that. Fund recipient. RPC transaction simulation failed. Custom program error. What does this mean? Error processing instruction 0. Or maybe what I'm trying to do is actually silly. Trying to put it back. Maybe that's not something that we can do. Okay. So we created a fungible token already. Okay. Let's see what that's like. Let's see what this does. I have to replace the with the token. I think it's this one. And then this one is the owner. So let's do, I think this is the owner. What's the JSON RPC thingamajig of this one? 8899. Let's do that. $8899. Found nothing. Let's play around a little bit. Put some fictitious data. Failed to process the bytes because it was failed. Parameters. What does this parameter do? Maybe that's just some keyword that we need to live with, maybe. Oh, there it goes. Let's just pipe that to JQ so it's prettier. So I found an account that has that. This is the owner. This is the token that was minted. It is initialized. The amount is a lot. The amount is 50. Oh, this is the LAMP ports, right? It's 50 billion. Okay. What is a LAMP port? LAMP port Solana. Fractional souls, right? LAMP port. LAMP ports mean a fraction of a soul. And I bet this, if we multiply this one by this one, this would give us 50, right? So that's the fractional amount. So that's how many LAMP ports. That makes sense. And then the program is Solana programming language token. And this is the owner. Where did this token keg something come from, actually? Maybe it came from our example a while ago. Create token, balance, supply. Yeah, I'm not sure. What is that? I'm not actually sure what that is. Okay, yeah, I'm not sure. There's a rich set of JSON RPC methods available for use with SPL token. So it's a way to find out the balance. Okay, that's pretty cool. Okay, creating a new token type. A new token type can be created by initially using a new mint with the initialize mint instruction. The mint is used to create or mint new tokens, and these tokens are stored in accounts. A mint is associated with each account, which means that the total supply a particular token type is equal to the balances of all the associated accounts. It's important to note that the initialize mint instruction does not require the Solana account being initialized also be a signer. The initialize mint instruction should be atomically processed with the system instruction that creates the Solana account by including both instructions in the same transaction. So this is the point where I may have personally reached my limits of reading and tinkering around. So I'm gonna hard stop here. So what were we able to accomplish today? We read up on Solana's SeaLevel parallel processing runtime while we had a lot of energy, and we were able to accomplish that. Excellent. Then we ran through the token program and ran through all of these examples of creating your own fungible token. And we reached the part where we were tinkering around with the JSON remote procedure call methods. And that was pretty good. And I think that's it for today. That's what doing a shitty job looks like for now. So thank you for joining me, and let's study more things and play games. Thanks. Bye-bye.